What do scientists do whenever they want to learn something new or find out something new? Well, scientists experiment. They run through experiments. Now, how do these experiments work? What do they do? What are the steps they follow? Well, scientists follow these steps. Question. What is your question you were trying to answer? What is the question you're trying to answer? And then hypothesis. You have to form a hypothesis, which we know is just a prediction that you explain why that prediction would happen. Okay? And then you get the materials, you run through steps in the experiment, which is the research part, and then you collect the data of the experiment, what happened in the experiment. And then you see what that data shows. Maybe you were right, maybe you were wrong. Okay, now let's run through this. Imagine we wanted to do an experiment. We know that when water gets really, really cold, it freezes, right? But we want to know exactly at what temperature water gets really, really cold. So we ask the question, what temperature does water freeze? We ask the question, what temperature does water freeze at? And then we form a hypothesis. We say, well, I think water freezes at 32 degrees Fahrenheit. Because at that point, the water molecules get too cold, they stop moving, that they're not able to wiggle freely around. That's the temperature, I think. Or cold enough, or you could say, use the hypothesis, say, I think it's going to freeze whenever the temperature gets cold enough where the water molecules start to stop moving so much. And they start to stay in place. And then you get the materials. You get maybe like a bucket of water. And then you run through the steps. You put it in a freezer at different temperatures. And you collect, and you let it wait over time. And you collect the data at each temperature. And you see whether your hypothesis was right or wrong. And you might see why it froze, what temperature it froze, but that's the general gist. And this is called the scientific method, where you form a question, come up with a hypothesis, you research, then you collect the data, and you see what that data says. Now, let's run through another experiment. All right, let's go with a simple one. Let's say that you like tuna. You like eating tuna. I don't, but let's say you like eating tuna. And one of your friends wants you to try, let's say, sardines. So you form a question, well, will I like sardines? Then you form a hypothesis saying, maybe I'll like sardines. You form a hypothesis saying, yes, I think I will like sardines because I like tuna, and they're both fish. So it's a prediction you gave that has a reason as to why you think it's true. And then you go and you eat the sardine, you collect the data, which would be your taste, seeing if you like it, and seeing if your prediction was wrong or not, and why. Maybe you didn't like sardines because they taste completely different from tuna. Maybe they taste a lot like tuna and you liked it. But that's a more simple version of how scientific experiments run. But that's also a scientific experiment. No, so this is how the scientific method works. You ask a question, form a hypothesis, get materials, go through the steps of the experiment, collect the data, and you come up with the conclusion. And this is really helpful for experimenting and learning new things. It's very, very, very important. Oh gosh, I'm tired. Stay at school.